The solar seahorses will solve the problem of high-emission vehicles by creating a fast, efficient, and reliable solar-powered model car for Professor Wiens and his future students to observe. On January 5th, 2023, the solar seahorses were formed and tasked with designing and creating a self-propelling solar-powered model car. To properly define our problem, we had to determine our functions, our objectives, and our constraints. In our design, the more aesthetic, the better, and the lower the embodied emissions, the better. We began the design process with research into drag, aerodynamics, and embodied carbon, as well as the best type of solar panel that we could use for our vehicle. With a firm grasp on the problem at hand, we began thinking about the design for our car. We thought of multiple ideas, including a bare-bones car with a flat wooden base and a small windshield, a spring idea that would move the solar panel closer to the light, a car with the solar panel as part of the body, and a car with multiple panels angled both directions. All of these ideas, we discussed what worked and what didn't, and decided on a wooden car design with an integrated solar panel. We decided this because of the light capture, as well as the low carbon emissions of wood. Next was fabrication. We used a solid 2x4 for the base and square wooden dowels for the rails that would mount the solar panel. The car's axle and motor mounts were attached to the base using screws, and then the axles were fed through the mounts and the tires were attached. The mounting rails and the base were then glued together, and the spoiler was glued to the back. The panels were connected in parallel to provide more torque and then mounted using double-sided tape. The wires from these panels were ran through a previously drilled hole in the base, and after all of this, the car was completed as expected. The car was tested multiple times and originally was having difficulty crossing the finish line. Balloons were added around the driving tires, and then the car was able to complete the race as expected. Next was race day. The crowd gathered, ready to compete. It was race time. The starter counts down. 3, 2, 1, go! The cars raced down the track, but ultimately we lost the race by a hair. In conclusion, the car worked as expected. It was light enough to avoid a penalty and satisfied every constraint. From this project, the group decided that next time we would use more of our budget on more kit solar panels and instead accept the weight penalty. All in all, the production process was a success and the group was able to become good friends.